Hello everyone, I'm Mr. Eric Atifa, and I'll be taking you through this section. That's the lesson about C programming with C++. So in this lesson, we'll talk about the objectives about C++. So this is the outline, as you can see on the screen. We'll talk about the introduce to C++, then why we should use C++, learn differences between C and C++, learn the object-oriented concept of C++, learn standard library components like IOStream, understand the C++ program development process flow, difference between process and thread, explore C++ program in code blocks. So we've come to the main lesson for today, and that's what C++ actually means. So in this case, we will talk about some few history behind C++ for everyone to get a clear clarification about what we're about to do today. So to begin with, C++ was created by a brilliant computer scientist named Eugene Strostrup in 1979. That's over 40 years ago. Initially, it was called C with classes. If you are wondering what classes means, don't worry, we will explain that later. The name C++ was actually coined by Ray Massey in 1983. The C++ part is actually a programming symbol. That means add one. Yeah, the plus plus means add one or make it better. That's the meaning of the plus plus. So literally C but better. The language was commercially released in 1985 and it evolved from C programming language in 1998. International standards were established to ensure C++ worked the same way across different computer systems wide world. So that's the history behind the C++. So we will continue with why we use C++ in our daily programming languages and stuff. So let me talk about that. So now you might be asking why should I learn C++? That's a question that most of the programmers or the beginners always ask. Why is that we should use C++? So with this, I will let you know why programmers often use C++ in their daily programming languages and stuff. Let's continue. So there are so many programming languages out there. That's a great question. Yeah. First, C++ is used in virtually every computing system you can think of, from your smartphone to the biggest supercomputers. C++ is there making things work. And also, it's incredibly efficient and close to the machine. This means C++ program can run very fast. It can run very fast and use computer resources effectively. It's what we call a system programming language. Perfect for you. Perfect for use. Computer perfect for building operating system. Sorry, the C++ is perfect for building operating system, games, and high performance applications. It's not easy. C++ supports object-oriented programming, which we will explore details. This makes it easier to organize and manage complex programs. C++ is a compiled language, which means your code gets translated into machine language before it runs. This makes it faster and interrupted language. Okay, so C++ also allows you to write modular programs that can work on various platforms. So like the Windows, the Mac, Linux, and other softwares that you can think of. So that's the history behind the C++ program. So we'll continue with the object-oriented programming. So with the object-oriented programming, this might sound complex, but let me explain it using a simple analogy. Imagine you are designing a car. In a traditional programming, you might write separate pieces of code for the engine, the wheels, the steering wheels, and so on. In object-oriented programming, you create objects that represent real-world things. That's for the object-oriented program. So let me continue. So you'd have a car object that contains all the data about the car, like its color, speed, and fuel level, along with all the operations you can perform on it, like start the engine, accelerate, or brake. Each object combines both the data and the operations that work on the data into a single unit. This makes it this makes your programming more organized, easier to understand, and easier to modify. Sorry. Okay. So let's continue with our object-oriented programming. When we use programming language, implementing that's the object oriented programming. We mean it provides tools and features that makes it easier to create and work with objects. As you learn C++, you will discover three important things. Yeah, take note. We will discover three important things that will help us to explore very well when using the C++ program. So let me start. So first, how to represent data in computer memory. Let me try to talk a few things about that. This is like learning how to store information about your car object. Yeah. Second, how to manipulate that data, like changing a car's speed or fuel level. And thirdly, how to implement operations like the actual code that makes the car accelerate. Okay, so you also learn to write algorithms, which are step-by-step instructions for solving problems that we already know what algorithms, and implementing them in C++ is just a simple stuff. So let's continue with our lesson. Okay, we will talk about object-oriented programs like combining data and operations. I think um, I think this is it. This, yeah. So the key insight of object-oriented programming is learning how to combine data and operations into a single unit called an object. This is because it's minor how we think about real world things. C++ was specifically designed to implement object-oriented design, or OOP. But here is something important. The OOD doesn't replace structures design, it works together with it. Think of it as adding new tools as your toolbox, not throwing away the old ones. So the OOD means the object oriented data. Yeah. Okay, so we talk about object oriented programming. That's data abstractions and escalations. Yeah, sorry. So let's commence with that. Now let's talk about some key object-oriented program concepts. Don't worry, these terms sound intimidating. Break them down. So let's continue with what first, data abstractions. So I like to talk about the data abstractions and why we use them in object-oriented programming and stuff. So this means creating classes to describe objects. A class is like a blueprint. If you want to build a car, you first create a blueprint that shows that every car should have and what it should be able to do. Secondly, uh, with the data escalation, this means controlling access to object data. Going back to our car example, you don't want to you don't just want anyone to directly access the engine. They should use the navigation key. That's the escalation works the same way in programming. And also we'll talk about the inheritance. That's by creating uh, and deriving classes. So let me talk more about that. This allows you to create new classes based on existing ones. If you have a general vehicle class, you can create car, trucks, and motorcycles. Classes that inherit common features but add their own specific characteristics. Okay, so let's move on to polymorphism. That's Greek for multiforms. Yeah, polymorphism. Let's talk a few more about polymorphism. Okay, so the final key concept is polymorphism. This is a Greek word means many forms. That's what I already said, multi-forms. Like, yeah, many things like many forms. And it's actually simpler than it sounds. I guess people will think that this because the sound is weird, it will be something difficult, but it's actually a simple something. So we will talk more about that. So let's polymorphism means the same instructions can have different effects depending on the context. For example, if you tell different vehicle to start, a car starts its engine. A bicycle doesn't need to start anything. And an electric vehicle starts silently. Same instructions, different implementations. This makes your programs more flexible and easier to extend with new features. That's what the polymorphism it, it means a different thing altogether. But it's actually the same thing by a different structure altogether. So let's move on to the next next thing. With this, I would like to introduce you to a simple C++ programming. So let's look at our first C++ program. Don't worry if it looks confusing at first. We break down a bit simple now. Okay, the first line that is the hash include IOS true. Now the computer to include a library for input and output operations. Think of it as important tools you will need. So that's simple. That's very simple. And let's move on to the second line that's using namespace and string. So using namespace is like saying I'm going to use the standard set of tools. So I don't have to write std every time. That's simple too. And moving on to the third one, we have the main obliquely. Let's talk about that too. So the main obliquely, that's parameters. It's where your program starts executing. Every C++ program must have a main function, and let's move on to the count. That's the fourth line. With the count is used to display text on the screen. That's the same as we always use the cout. That is the outside. That's right. That's a simple source. It's the symbol. The rest is the out. And time is and time is like present time. Now it's about to go to the next time. That has been the end time. Okay. And yeah, we have with the operations. The operating system that the program finished successfully. So without the return zero, the rules that if you didn't go to one, yeah, of course, if you return the return zero, that means basically it means the code you return is not complete. Let's say that it's not complete, it's not complete, it's one. That and so this is the basic code. So we have to explain what the has included means. In the STD, and each may the count, the and everything. I hope you have a clear understanding about it. So now let's move simpler and easier. Now let's move on to the processing a C++ code. So processing a C++ program. So let's talk a few things about that. It's very simple. Let's now let's understand what's happening when you want to run a C++. This is a step-by-step process, like following a recipe. Like following a recipe, step by step. Like you cooking. Yeah, let's recipe out to follow so that your food will be right and food will be. It's simple. Let's look at what the evidence sound. First, use an editor to create your source program. This is just text file to your C++ code, like the example we just saw. Some statements in C++ begin with hash, like hash include. These are called process preprocessor. Yeah, preprocessor directives. So let's go back to our code. So what we just saw here, the hash include ION stream, basically the big is preprocessor directive. See, now we have a good understanding about that. So now let's go to that follows for all the symptoms, but still doesn't stop the problem we wanted it to stop. That is why that's why testing is so important. Not just want to understand let's talk about the process. The process is simply a program that has been loaded into the brain along with all the resources needed to run. Because the key is like as we are power and become the process like actually cooking the using hours as the key fullness if it is it is like yeah put it in the sorry up to secret process one now is what get let's understand what it what try is the process is like every student the trend like the individual multiple thread can be created from the same process. Some processes are single threaded. They do one thing at a time. Others are multi-threaded. They can do multiple things simultaneously. This is particularly important in modern programming, where we are often want our programs to do several things at once, like naming the object while downloading a file, while also responding to user as the trend as the noise switching the virtual representation of features. So this actually shows the virtual representation of features. So this slide software appears to show the virtual representation of features described in the data based on the virtual content. Now let's proceed to the thread and processing program. That's simple. It's simple. It continues as your program becomes one or more running processes. Remember, processes are typically independent of one another. They have their own memory space and resources. In each process, the thread exists as subset of thread has different tasks that the process can perform. Here is a key point to communicate with each other more easily than processes can. This is because within the same process share the same memory space, while processes are isolated from each other for security and stability. So this is a clear understanding. So now so this brings us to the end